In this video, I'm going to show you how to compare fractions with unlike denominators. So unlike denominators means that the denominator, the bottom number in your fraction, these two numbers here, are unlike. They're not the same. They're not both 12 or both 8. We have an 8 and a 12, so they're different. And so the instructions here say complete the inequality with the statement less than, greater than, or equal to. That's those mean. So sometimes they won't actually say, they won't give you the less than, greater than, or equal to symbols. Sometimes they'll just say complete the inequality statement. Sometimes it'll just say that. So whenever you hear that, you know that you're basically saying, is this one bigger? Or is this one bigger? Or are they equal? Okay, that's what that means when it says complete the inequality statement. So I'm going to show you two different ways of doing this because it's always good to know at least two ways of doing something so you can do the opposite way to double check the first way, okay? So I'm going to start off by showing you with a visual model. I think that will kind of help you be able to visualize what these fractions really mean. So if I have 2 8s here, I'm going to show you 2 8s as a visual model in a tape diagram on this page here. So 2 8s I'm going to represent right here in this one, this column. So I'm going to start off by just writing our fraction down so we don't forget. This one is 2 8s. Now I already broke apart this tape diagram for you earlier to save us some time on the video. So you can see I have 1, 2, 3, 4, 5, 6, 7, 8 boxes here. That's where this 8 down below is. That denominator means we have 8 total parts. See, we have 8 total parts here. And then the 2 means out of our 8 total parts, we have 2 that are shaded. So I'm going to shade in these first 2 here. Okay, that's 2 8s. Now, we have 4 12s for our other one here. That's our other fraction we're comparing. So we're going to compare which one's bigger, which one is, or was one bigger than the other, or are they equal? So let's figure that out. We're going to make 2 8s here. So, or sorry, 2 12s here. So you can see I've already broken up this bottom one into 12 boxes because this one is 4 12s. See, 4 12s. So we have 12 total parts down here, and we have 4 that are shaded in. So I'm going to shade in these 4 here. And you can see, just by looking, we can tell which one is shaded in, which one is more. See, this 4 is shaded in more. This top one here, these 2 that are up here, they would need to shade in about this much more of this 3 box here to be equivalent to the 4 12s. Do you see that there? Okay. So that means that 4 12s is bigger. We have more shaded in here. We have, think of it if this was like a chocolate bar. Would you want this one here, this one down below here? Or would you want the smaller one up top, right? Okay, so that means 4 12ths is greater. And a lot of you learned this, I'm sure, in 3rd and 2nd grade, but you know which way these point. You remember the crocodile. So do you see crocodiles are always really hungry. So they want to eat the bigger fraction. See how it's eating the bigger fraction? Because 4 12ths would be a bigger piece of something than 2 8s. Okay? That's the first way I'm going to show you. The other way that I'm going to show you, because you should always be able to have another strategy to double check, is we're going to turn our denominators, our bottom numbers here, into common denominators. So they're unlike right now because they're not the same. They're different, and we're going to make them the same. And the way that you do that is you find a multiple that they both have in common. Remember our multiples? So like the multiples of 8 or the multiples of 12, if you just count up from there. So for example, you could go 8 times 2, which is 4. So 8 times 8, 16, 24. I'm just listing the multiples of 8 down below here. Okay. And then 12 be 12 24. Do we have any that are in common? I just counted up basically from 8. 8, 16, 24, and you can keep going, keep going, keep going. But I thought to myself, wait a minute, I know that 12, the next one would be 24. So do you see how they both have the same multiple? They have a common multiple. So that means that we can actually find a way to change our 2 8s and 4 12s to both have 24 in the denominator, okay? So I'm going to show you that below here. So I have our fractions 2 8s. We have 4 12s. Just writing them down here again. And I want to change both of my denominators here to be 24. Okay, I want to find a way to make them 24. So how can we do that? Let's see. Well, we know the multiples of 8. We wrote those down. So it'd be 8 times 3, because see, it's 1, 2, 3 over. So if I multiply the top or the bottom by 8 to make this 24, I need to do the same thing with the top, right? We'll actually move this over to the side for us. We have a little space here. Okay, so I'm multiplying the bottom by 3. I've got to multiply the top by 3. So now I know 8 times 3 is 24. Okay, and then 2 times 3 is 6. So now, instead of having 2 8s, I'm going to cross it off and I'm going to make it 6 24ths. Okay, and I'm going to compare that, but we've got to do the same thing down below. Now, I don't need to multiply this fraction here by 3, because I'm not going to get 24. Because didn't we see up here when we wrote on our multiples that it was the next one? So that means 12 times 2 is going to give us 24. So I'm going to multiply this by 2. Means I have to multiply my 4 by 2. You've got to multiply the top and the bottom by the same number here, okay? So 4 times 2 is 8, excuse me. And then 2 times 12 is 24. So now I'm comparing 6 24ths by 8 24ths. And it's so much easier to compare fractions that have the same denominator, because then it's really easy all you have to really ask yourself now is what's bigger, 6 or 8? Because the denominator is the same, so it really doesn't matter here. I'm going to actually just map both of these though onto a tape diagram in case any of you are feeling like, this is too much information for today. So I'm going to show you both of these in a tape diagram so you can really see how easy it is to compare fractions when you have the same denominator. Because see, before we had different denominators, we had an 8 and a 12, so you had to kind of compare them side by side. But when you have the same one, that's a lot easier. So you have 6 24s compared to 8 24s. Top one is 6 24s and 8 24s. I already created 24 boxes, and I won't waste your guys' time counting them all, but just know that this top one here, they both have 24. There's 24 total boxes here in each. Okay, and I'm going to shade in, and actually I'll type this for you guys just so it's a little bit cleaner. This top one here, 6 24ths. And these slanted fractions, when you have fractions like this is a good reminder. That's the same thing as, but sometimes we can't type this option right here, so we type this option here, just so you know, okay? So I have 6 24ths on the top here, and down below, I have 8 24ths, okay? So I'm just going to highlight in six on the top here and 8 on the bottom here. So 1, 2, 3, 4, 5, 6. I went over a little into my 7 there, but I'll erase it a bit. Okay, so see, let's just double check really fast. 1, 2, 3, 4, 5, 6. Okay, now down below here, I'm going to shade in 8. 1, 2, 3, 4, 5, 6, 7, 8. And I'll just count them for you again just to show you. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So now it's super easy to tell because look, we have the exact same number of boxes, 24 in both, and it's super obvious that 8 12ths is more, plus we just know 8 is more than 6, right? Okay, so that means that 8 24ths is also bigger than 6 24ths, and 8 24ths and 4 12ths, they're the same. They're equivalent. 8 24ths. They're equivalent because all you would need to do to get from one to the other is multiply by 2. That makes sense? See up here? 4 12ths and 8 24ths. And same thing with 2 8ths and 6 24ths. Because here, we would just need to multiply by 3. Okay, guys, I know that was a lot today, but feel free to rewatch the video if you need to. Try to remember to do 2 different strategies. Here we did visual model, and then we created common denominators with our 24s. Okay? If you have any more questions, ask your teachers or leave me a note in the comments.